Okay, getting ready for our work and energy test. Last test for my midterms. It's pretty hard. All right. First question asks us to rank from highest to lowest kinetic energy. So our highest kinetic energy is going to be at the bottom, and our lowest kinetic energy is going to be at the top. Because as something falls down, it's going to gain in speed. So the bottom, it's gained a bunch of speed and it's going faster. At the top, it hasn't gained that speed, so it would be going slower. So the highest kinetic energy is hard to tell. You can just put C or F. I just put them both. I don't really know which one's lower than the other. And then next lowest would be D, and then B, and then E, and then A, I think, is the highest point, so it would be the least kinetic energy. What is happening to the potential energy from A to B? Well, potential energy depends on your height. From A to B, you are losing height. So if potential energy is mgh and height is going down, then your potential energy would also be decreasing. From A to B, your total energy is going to stay the same because energy is conserved. There's no work being put in, it's just falling down, so that total energy is doing the same. Now you might be like, wait, but we just said this is going down. That's true. Your potential energy is decreasing, but your kinetic energy is increasing because you're gaining speed, you're getting faster. A section where kinetic is going into potential, if you're converting into potential energy, that means you're gaining potential, so you're gaining height. So C to D works. You also could say from D to E, only like from here to here. So C to D is an easy answer. It takes 98 newtons of force to lift the roller coaster from the top of the track from the ground. If the track is 40 meters high, how much work was done? So this is a height, but I'm looking for work, and I've been given a force. So I'm going to use work equals force times distance. So I'm going to call this a distance. Technically, it is a height as well, right? Every height is also a distance. But in this formula, we want to use distance. So then 980 times distance of 40, that gives me a work of 39,200 joules. F is asking how much potential energy the car has at the top if it has a mass of 100 and a height of 40. Now you might be wondering, wait, we just called that distance, why is this a height? Well, because I'm looking for potential energy, and potential is mg height, not just any random distance. So I'm going to use it as a height. Mass is 100, g is 9.8, and height is 40. So I get that my potential energy is 39,200 joules, which we'll notice is the exact same thing. So why is it that my work to get up to the top is equal to the potential energy at the top? Well, work and potential energy are related because work is equal to the change in potential energy. So if you start from the ground and you end at this potential, then this is your change in potential, which is also my work. If there's no friction, then laws of conservation says that of energy says the total mechanical, so including both kinetic and potential, should always be the same number. And if the car has 25,000 joules of potential energy at C, then how much kinetic energy does it have to have at that point? Well, let's think about it. We just said that we started with 39,200, and I'm realizing now I didn't specifically say it starts from rest right here, but let's say it starts from rest right there. So my potential and my kinetic, that means that my total energy is just this 39,200. So if I look at point C and it's telling me, okay, my potential energy is 25,000 here, to find my missing kinetic, well, they have to have the same total, so I'm just going to subtract, because I need these two to add to 39. So if I subtract this one from the 39, that gives me the missing. So if you do the 39,000 minus the 25,000, you get that your kinetic energy at that point is 14,200 joules. H is saying if there's no friction, is it possible for the roller coaster to roll up to a height of 45 meters? Well, let's think about it. It's starting at 40 meters, and it's starting from rest. It's just let go. So it would be impossible for it to go up to 45 meters because the highest it can go, if it's starting from rest at 40 meters, is to go just to the 40 meters on the other side. Because energy has to be conserved. So if you're leaving and going up, at this point, all of your energy has been converted into potential. There's no extra kinetic, so you can't go any higher, because where would that energy come from? So no, because it starts from rest at 40 meters high. So there's only enough energy to reach 40 meters high on the other side. Can't go any higher unless you add in energy into the system. We're looking for how the gravitational potential energy would change if all of these things change. So let's look at our equation. Potential energy is mgh. If I triple my height, so instead of mgh I have mg times 3h, then that's a factor of 3 bigger, so it would be times 3. Which makes sense. If I have my pen right here and I lift it up 3 times higher, it's holding more energy, specifically 3 times more. If the mass doubles, that's 2 mg, which is a factor of 2 bigger, times 2. If I have half the mass, but I have twice the height, then what happens when you half and double something is those cancel out, so this would just stay the same. So increases by a factor of 3, increases by 2, stays the same, because increasing and then decreasing by the same amount cancels out. Now we're looking at how kinetic energy would change. So kinetic energy is 1/2 mv squared. I plug in twice the mass v squared. Now some of you might be saying, wait, but half of 2, that cancels out, it's mv squared. That's true, but mv squared is not what it started at. It started at 1/2 mv squared, so if it went from 1/2 mv squared to mv squared, that's a factor of 2 bigger. Or you can just think about it, okay, this is how it started, this is now a factor of 2 more than before, so it is bigger times 2. Mass remains the same, but velocity doubles, so let's think. Most of you are tempted to just say times 2, but that's actually not what's happening here. Because the v is getting squared, anything that you do to the v gets squared. So getting twice the velocity gets squared, so really it's like 4 times v squared. So that's going to be a factor of 4 bigger, because whatever happens to velocity gets squared. If the mass is halved, so that's like half of the m times twice the velocity, but it gets squared, so that's like a factor of half times 4, which leaves me with times 2 still. And then mass doubles, so 2m and twice the velocity. Again, the velocity gets squared, so that's like 2 times 4, which is 8 times bigger. So trick there is whatever happens to velocity gets squared. Not getting doubled, because if I have 3 times the velocity, that would be 9. So make sure you're not just multiplying by 2, you're actually squaring the number. It just happens that 2 squared is 4. Okay, roller coaster problem. So I have been given all of these heights, so I'm going to go ahead and put in heights. And if you look at point 1, I have height, velocity, and potential. Now I haven't been given the mass, but I have been given the potential and the height. So I can plug into the PE equals mgh. 58.8 is my PE. Mass is what I'm looking for. G is 9.8. Height is 2. Now I can simplify the mass times 9.8 times 2 is just 19.6 mass. And then to get m by itself, divide 19.6 over. And that's going to give me my mass is 3. And my mass is going to stay the same the whole time. It's not changing. So once I find it, now I'm good. Now I need to find kinetic energy. Some of you are tempted to say 0 because a lot of times it starts from rest. It does not start from rest. In fact, it starts at the velocity of 15. So now we're just plugging in 1/2 mv squared. So 1/2 mass of 3, 15 squared gives me a kinetic energy of 337.3. Let me double check. Nope, 337.5. And now the point of finding, other than filling out the chart, the point of finding both velocities at the first point is so that we can find our total energy. So total energy includes both types of energy. So if I'm starting with 58.8 joules of potential and 337.5 joules of kinetic, that means I have a total of 396.3 joules together. And if you're wondering how I got that, the two of them added together gives me this total. And we know that our total has to stay the same at every single point. So that's the whole point of finding at the beginning is now, okay, my total has to be 39.6 at every single point. Now we look at point 2. I've been given the height. If you have height, you can find potential. So potential is mass times gravity times height. And that gives me a potential of 294. Now we can't find kinetic, or we can't find velocity without kinetic, and you can't plug in 1/2 mv squared to get kinetic because you don't have v, but we can use that the total energy is 396.3, so this is my potential. Whatever's missing just comes from whatever's missing from the total. So I'm just going to do my total, the 396.3, minus the potential that I have, and that's going to give me the missing kinetic, which in this case is 102.3. And once you have kinetic, now you can find velocity, because kinetic is 1/2 mv squared. Kinetic 102.3, 1/2 mass of 3v squared, half of 3 is 1.5. Now to get v by itself, divide the 1.5 over, and that gives me, I didn't show my work on this, v squared equals, I can just get my calculator real quick. 68.2, and now we just take the square root. And that's where I get the 8.26 as my velocity at point 2. Now the rest of these problems, because I'm given height at all of them, is doing the same thing. Once you have height, you can do the MGH, just plug in our new height, and that gives me a potential of 147. If you have potential and you know the total, you would just subtract total minus my potential, gives me a missing kinetic, which is 249.3. And once you have kinetic, you plug in kinetic is 1/2 mv squared, and then solve it just like we did here, except for now you have a new kinetic, so you have a new velocity. I'm not going to rework all of these because if you get stuck, you can just go back and rewatch part point 2, but I will put the answers up so you can double check with yourself. In this one, it's easy because your height is 0, so that means my kinetic is just the total because height is 0, and that would be my fastest speed because that's the most kinetic, and these are my answers. Another quick check is like all the lower points should be faster than the higher points. So like this is the lowest, it has the fastest speed. This is the next lowest, it's the next fastest speed. Then 3, which is the next fastest, and then 5, which is the next fastest, and 2, which is the slowest. So that makes sense. Number 5, I've got a 6 kilogram bowling ball, and it's tied to the end of a 4 meter long string. The other end is tied to the ceiling. It's pulled back, and then it falls through like this, and it's released from rest, meaning your kinetic is 0 here. But I do have some potential because it's some height above something. And then we want to find the speed right here. So think about, at this point, the height, or it's fallen down 4 meters because that's how long the string is. And let's pretend it was on the ground. Then your potential would be 0 here, and my kinetic energy would just be the potential I started with. So let's find potential at the top. Mass times gravity times height of 4 gives me a potential energy of 235.2. Now I go to the bottom. Now I've lost my 4 meters. Now I'm don't have any height anymore. No potential, so my kinetic is just transferred to 35.2. So this is one of those cases where it goes from all potential to all kinetic. We know it doesn't have to do that, right? We did a bunch where they were not equal at all, but there are cases when the other energy is 0 that it's completely transferred. Now we're looking for speed. Kinetic is 1/2 mv squared. Kinetic is 235.2. 1/2 mass of 6v squared. Half of 6 is 3. Divide the 3 over. Divided by 3. That gives me 78.4 v squared, and now you just take the square root, and that gives me my velocity is 8.85 meters per second. In a physics demonstration, a bowling ball is hung by a wire. The teacher pulls it back. This is their nose right here. They release the ball, not pushing it. Do they need to step back? And you guys should say no, because you've seen it. We didn't use a bowling ball. That would be dramatic. But no, in our reasoning, is conservation of energy. If you're not giving it any extra velocity, if you're just releasing it, then it's starting with only potential energy. So if energy is conserved, then it only has enough energy to go exactly where it started with. So the ball only has enough energy to reach where it started. Now, if you gave it a push, you'd be adding some kinetic energy into it, so you'd be increasing the energy in the system, meaning it could go higher than before. Jane, looking for Tarzan, running at a speed of 5.6, grabs a vine that's hanging up and down, and then it goes up. So similar to this one, except for we're starting on the bottom and then going up. So the type of energy she has running on the floor would be all kinetic energy, because your potential is 0 on the floor. And the type of energy she has at the maximum height, well, think about as she goes up, she's losing her speed, she's increasing in potential and decreasing in kinetic. At the very, very top, it's all potential energy. Your kinetic would be 0, because if she still had some velocity, then it wouldn't be the maximum height. She'd still be able to go higher. And we're trying to find the actual height that she goes to, so that means we would need to find this potential energy, which means we need to find the kinetic energy. Now you might be saying, but I don't have a mass. That's true. And we also don't have any other information to help us find the mass. So for right now, let's just use m. So 1/2 times m times 5.6 squared just gives me 15.68 m. If you're wondering where I got that, 1/2 of 5.6 squared is 15.68, and the m is still there. So then that's what I'm going to put in my chart, and it's okay that it has an m in it, because I don't know the mass. So that means my total energy is just this. When it goes up to the top, kinetic is 0, so my potential is the 15.68 m right here. And I'm going to use my potential to find my height. So potential equals mgh, potential being 15.68 m equals mass times 9.8 times height. Trying to get height by itself, so let's divide the m's over. Oh look, they cancel out, which is why it's okay that I didn't know the mass. And then you still have to divide the 9.8 over, and that gives me a height of 1.6. Number 8, we have a high jump. The kinetic energy of 15 kilogram athlete is transformed of a 15 kilogram athlete is transformed into potential energy without the use of a pole. What is the minimum speed she needs to have on the ground? So I need to find her speed here. On the ground, potential is 0, so it's all kinetic energy. If in order to lift their center of mass 2.1 meters above, meaning they have some potential energy right here, and they still need to be moving with the speed of 1, so they have both potential and they have kinetic here. Really should have given more room. So let's find the potential and the kinetic needed at the top. Well, potential is mg, height of 2.1. So that gives me a potential energy of 308.7. And then I still need some kinetic, because it can't be just like stopped at the top. It needs to still be moving at 1 meter per second. So 1/2 mass of 15 times 1 second squared, or 1 meter per second squared, gives me a kinetic energy of 7.5. So I need this much potential and this much kinetic at the top, so I need to find how much kinetic I need at the bottom. Well, total energy is conserved, so my total energy here is just the two of them together, which is 316.2. So then that's how much kinetic I need at the bottom, because potential is 0 there. And trying to find the speed, so kinetic equals 1/2 mv squared, 13.6. Or 316.2 equals 1/2 mass of 15 v squared, 7.5 v squared. Divide the 7.5 over, and then you take the square root. Your missing velocity is 6.49. And we knew it had to be even, like it had to at least be more than 1 meter per second, because on its way up, it's losing speed and gaining potential. So it had to be faster at the bottom than it was at the top. Skateboarder has a mass of 30, ends up with a final velocity of 7, and after 220 joules of work, what was the initial velocity? So we have 3 equations for work: FD, change in potential, and change in kinetic. Because I'm looking for initial velocity and I have final velocity, that tells me I'm going to use the change in kinetic energy. Change is always final minus the initial. Kinetic energy is 1/2 mv squared. So it's 1/2 mv squared minus 1/2 mv squared, and what's changing is the velocity. And we always do final minus the initial. And this is my equation, so now I just plug in. 220 equals 1/2 mass of 30 v final 7 squared minus 1/2 mass of 30 v initial squared is what I'm looking for. put this term into your calculator, you get 735. 1/2 of 30 is 15. Now, you cannot combine 735 minus 15 because they are not like terms. So what you need to do is you need to move the 735 over. That's going to give me minus or negative 515 equals negative 15 VI squared. Now I can divide the negative 15 over, crosses off, so I get VI squared is equal to 34.33. And then my last step is to square root to undo the square. You get your initial velocity is 5.86. And we knew it had to be less than 6 because you put work in and it gets faster, so it started slower. Ball is dropped from 8 meters high. If it's dropped, then your kinetic energy is 0 at the top, but you do obviously have some potential. I want to know how fast it's going at 3 meters high. Here you have both potential and you have kinetic. I have not been given the mass, and I've only been given height, so it's not like I can use something to find the mass. This is another one where we will just use m. So let's start. If I have heights, we can find potentials. So mass times gravity times height of h gives me a potential energy of 78.4 m. And then potential mass times gravity, but a height of 3 now, gives me 29.4 m. Well, because this was dropped, that means my total energy is the 78.4 m. So if I have potential of 24.4 m and my total is this, you can just subtract from the total to find your missing kinetic. When you subtract, you get 49 m. It's just this minus the 29.4 to get your 49 right there. And then now that you have kinetic, you can find the speed because kinetic's 1/2 mv squared. So 49 m is your kinetic energy, 1/2 mv squared. Divide your m's over. Ooh, they cancel again, which is exactly what you want. You can think of the point, this 1/2 is 0.5, so 49 is 0.5 v squared. Divide 0.5 over, you get 98 is v squared. And then you can take the square root and you would get 9.9. Yeah. That's your velocity. For those of you who maybe didn't get 40 or 98, you might have divided by 2. Dividing by 0.5 is not the same thing as dividing by 2, so just be careful with that. Here, so at which point does a skateboard have the most kinetic energy? Well, most kinetic goes at the point where it has the least potential energy. Well, we have a graph of the potential energy, so the least potential is at point C. So where it has the least potential is where it has the most kinetic, because those do the opposite things. When I'm losing this potential energy, it doesn't disappear, it goes into kinetic. Where is it at rest? So at rest means your kinetic energy is 0, which means you have all potential energy. So the point where you have the all potential energy is right here. If you look, this is only potential. It has no kinetic because your potential is your total. So point A. And we want to sketch a graph of the kinetic energy at like A, B, and C. Well, here, if my potential is the total, that means I start with no kinetic energy. Here, I have no potential energy, but I still have energy, so that means it's all kinetic energy, so it's going to look like the exact opposite, like this. And that at least checks out with our answer choices, so the most kinetic is at C, and it's at rest, 0 kinetic at point A. How fast is the box moving at the bottom? If it starts from rest at the point shown, if it starts from rest, its kinetic is 0, so I'm starting with potential, and my potential energy would be mass times 9.8 times the height, which is 9.5. Make sure you use the height, not this angle distance. Again, I don't have mass, and I don't have any way to find it, so we'll just leave it in terms of m. So that gives me 93.1 m. And then when we go to the bottom, your potential is 0 on the ground. So then all of that energy was transferred. You get 91 or 93.1 m is your kinetic. And we're trying to find speed. So 1/2 mv squared and finding speed at this point. So 93.1 m equals 1/2 mv squared. Divide the m's over. They cancel. This is 0.5 v squared. Divide by 0.5. And you get 186.2 is v squared. And take the square root. Ooh, that's not a square root. And you should be getting 13.65. We've got a block of 2m going at a velocity v and a block of m going at a velocity of 2v. and we want to know how the kinetic energies compare. Now, most people, the mistake here is they're like, oh, doubling, but then doubling, then they're both the same. That's actually not true, because your kinetic energy is 1/2 mv squared. So because this velocity gets squared, this doubling right here isn't like a doubling, because 2v getting squared is really like a factor of times 4. And here, twice the mass is a factor of times 2, because mass doesn't get squared. So if I'm doubling it and quadrupling this one, then that means this one is twice as big as this one. You also can think about it as like actually plug in. So 1/2 2mv squared gives me just mv squared. Here you plug in 1/2 mass of m 2v squared, gives me 1/2 mass of 4v squared, which is 2mv squared. If you have mv squared and 2mv squared, then this one is twice as great. 1 kilogram rock is dropped from a cliff that is 90 meters high, so my potential energy is mgh of 90. That gives me 882. And if it's dropped, kinetic energy is 0. If it's fallen down 20 meters, now it's at a height of 70 meters. So you can find your potential energy is 1 times 9.8 times 70. And that gives me a potential energy of 686. So I need to find my missing kinetic. Well, energy is conserved. I started with 882 and 0, so my total energy is just the 882. So you can just subtract the potential from the total to get my missing kinetic at that point, and you get 196. This is rounded, so 200 is close enough. 3 people of equal mass climbing a mountain with the different paths. Which one has the greatest amount of gravitational potential energy? So potential energy is mgh. They all have the same mass. They all have the same g because they're at the same place. So now it's just the height. Okay, they all start on the ground. They all end at the same height. So their potential energy is going to be the same for all of them. If an object falls near the surface of the Earth, the loss in potential energy, because it's falling down, so potential energy is going to decrease. Well, it doesn't disappear, so where does that potential energy go? It goes into kinetic energy, so that's equal to the gain in kinetic. So if you lose 10 joules of potential, you gain 10 joules of kinetic. 20 kilogram object strikes the ground with this much kinetic energy after falling freely. How far above the ground was the object when it was released? So if it's just released, kinetic is 0 at the top. We're looking for potential it starts with. When it hits the ground, potential is 0, and it tells me it has a kinetic of 1960. So that means it must have started with 1960, because your total right here is 1960. If this is 0, then it must have started with that much potential. And how far above, so looking for the height, so potential equals mgh, 1960 equals mass of 20 times 9.8 h. This is 196 h. Divided over, you get 10. 10 meters above the ground, your potential energy is equal to z, and it falls freely, so I think it's just dropped. Kinetic we can assume is 0. When I go to 1 meter above the ground, I want to know what my kinetic energy is. Well, let's think through potential, because we actually know the height. So if I have 10 meters high and I have z, when I go to 1 meter high, I only have 1/10 the height, so 1/10 the potential. So think about it as 1/10 z. Well, where did the rest of that energy go? Oh, it went into kinetic. So the amount of kinetic gains is 9/10 z, because they still have to add up to a total of z. So 9/10 z. And it makes sense that at the very, very bottom, it has mostly kinetic energy and a lot less potential. But it's not all kinetic energy, because it still has some height. So it couldn't be z. It would be z at the very, very end. At which point is the kinetic energy the least? So kinetic energy, the least, happens when potential energy is the most. So this is like the highest point. And then the most kinetic is when potential is the least. This is the lowest point. So the highest point would be like the start, or you can think about it as like point D, and then the most kinetic energy would be at point B. As it goes from B to C, what happens to potential, kinetic, and mechanical? Well, potential depends on height. You are increasing your height, so the potential energy is increasing. If you're gaining potential, that has to come at a cost. That means your kinetic must be decreasing, and that makes sense because it gets slower on its way up. And your mechanical energy is like your total, and this should always stay the same because energy is conserved. Ball starts with a velocity of 4 meters per second at point A. How fast is it moving at all of these points? So at this point, it has both potential and it has kinetic energy. So potential is mass times gravity times height. So this has a potential energy of 784. And then kinetic is 1/2 mass v squared. So I have kinetic energy of 16, and that's important because I need to know my total energy. The two of these together is 800. And energy is conserved, so that's going to be my total, that's me, at every single point. So now we go to point B. Again, I have both potential and I have kinetic. You have the height, so we're going to plug in mass times gravity times height of 20 gives me a potential energy of 392. Subtract from my total. If I have 392, but I have a total of 800, that means I have 408 kinetic. Go to E, my potential would be 0 here, which means my kinetic would be all of the energy, 800. At C, I'm back at the same height, so I can just use these same values again, because it's the same potential, and therefore the same kinetic, because the total has to stay the same. F, I have a new height, so I'm going to plug in mass times gravity times height of 10, and that gives me 196. And still has to add up to 800, so I'm going to subtract and get my missing kinetic as 604. Now I have the kinetic energy at every single point, so to find how fast, you're just plugging in KE is 1/2 mv squared. So let's start at point B. 408 equals 1/2 mass of 2v squared. Half of 2 just is 1, so v squared equals 408. So you just take the square root, and you get your velocity right here is 20.2 if you round up. Go to point E, so 800 equals 1/2 times 2 times v squared, so v squared is 800, take the square root, you get your velocity at point E is 28.28. At C, we don't need to do it again because these are the same values because they're at the same height and there's no energy lost. And lastly is point F, kinetic energy equals 1/2 mass v squared. That's just 1, so then you take the square root and you get your velocity is 24.58. Sorry, I should have given you more room on this one too. And it makes sense that the fastest is right here, and then the next fastest is right here, and then slower here and here, because as it falls down, it gains speed, and as it goes up, it loses speed. 3 kilogram object placed on a frictionless track at point A, released from rest, so kinetic is 0, my potential is just mg height of 3, so that gives me a potential energy of 88.2. So my total energy is 88.2, because 88.2 plus 0 gives me that number. And we want to know what the kinetic energy is at point B. Well, point B has both potential and it has kinetic, so let's find the potential. Mass times gravity times height of 1, so that just gives me 29.4. Yeah, 29.4. And then we're going to subtract from the total to get our missing energy at that point, and I get 58.8. And that's all I'm asking is the missing kinetic. You don't need to find the speed here. 22 is a challenge problem, so you have to do it. And if you really want to, you can, and you didn't get the answer on the answer key, then just come into lunch.